Okay, I'm back, and no, we have not changed lessons. So this is still a lesson about groundwater, but I wanted to show you a slide that we used in a previous lesson when we were talking about rivers. And we talked about the discharge of a river, which was going to be the volume flow rate. And we gave it the letter Q, and that was the amount of water that flowed in the river channel per second. And then we found out that that was equal to the velocity of the river, and then it was multiplied by the area of the channel. And then we found out that the velocity of the river was related to its slope. So it was the velocity of the river was proportional to the square root of the slope of the gradient multiplied by the area of the channel, and then it was divided by the roughness of the channel, and then it was multiplied or divided by the wetted perimeter of it. So that we ended up with this for our velocity, and then we still had to multiply it by the letter A. So this told us the amount of water that would flow per second above ground in a river channel. Now we want to compare this to the flow rate, the discharge under the ground. Okay, so now we're going to go back to our regularly scheduled lesson here. And now we're continuing to talk about why does groundwater move. So here would be the discharge. This would be the flow rate Q of the water under the ground. And you can see it has a more simple equation. So this was when it's in a river, and then when it's flowing underground, it would depend on what is it flowing through. So this is called the hydraulic conductivity, and this would depend on how permeable the rocks are, or the gravel, or the sand, or whatever material that it's flowing through. So that the bigger this number is, then the more easy the water would be able to flow through it under the ground. Okay, then it also depends on the area that the water is flowing through underground, and it also depends on the slope. So notice that, see this formula up here, it also depended on the area, it also depended on the slope, and then it also depended on characteristics of the river channel. Well, this depends on characteristics of the rocks that it's flowing through. All right, so I'm not going to have you do any actually plugging in numbers into this formula, but I could ask you, what would happen if the underground water is flowing steeper? Okay, it's flowing down a steeper slope under the ground. Would it be running faster, or would it be running slower? All things considered. Okay, so the S would be bigger, so that means that what would come out of the equation would get bigger. So that in general, water, if you've got two mountains, so here's a mountain that's shaped like this, and then you got a mountain that's shaped like this, and they both have water in it, the water is going to tend to flow faster when it's steeper than when it's shallower. Or I could say, what about if the water is trying to go through rocks that are not very permeable? What's that going to do to the flow rate? Okay, so that would mean it's not very conductive. So this number would be small, which would mean this number would be small. So again, the groundwater would be traveling slower through that kind of material. All right, let's take a break, and when we come back, we are going to talk about the chemistry of groundwater.